So we're beginning with some Algebra 1 stuff, Semester 1 stuff, just graphing with y equals mx plus b form. Line A I highlighted in red. I'm going to graph it in red. The b value is positive 1, so it crosses the y-axis at positive 1. The slope is negative 2 over 3, which means you're going to go down 2 over 1, 2, 3. And you could continue to go down 2 over 3, but you'd be off the graph. You could also use that pattern backwards, up 2 over 3 in the opposite direction. But the bottom line is you have your line right there, and that line has arrows. Yay? Okay, the next one. I want to go for line B in blue, y equals negative 2. That's simply a horizontal line crossing the y-axis at negative 2. Has no slope. Whoops, that's positive 2. Negative 2. It's totally flat, totally horizontal. Arrows going in both directions. Line C, I want to do that one in green, I guess. Y equals 4x minus 3. So it crosses at negative 3. From that point, I go up 4, 1, 2, 3, 4 over 1. Continue to go up 1, 2, 3, 4 over 1. And there's my line. Whoops, that was ugly. Anyways, you guys get the picture. Everybody should know how to graph using y equals mx plus b. If you don't, there's no way you could pass this next section, right? Piecewise functions. Because piecewise functions is doing exactly that, but then only showing the piece of each line that they want you to show based on the condition. So when we go to these functions over here, it's the same thing. Just like on the other one, we had y equaled negative 2 as one of the equations. Right here, you have y equals negative 2. Okay. What I'm going to do is I want to graph the y equals negative 2 in blue, but I usually rewrite the equation right next to it. So I like to write y equals negative 2. That is a horizontal line crossing the y-axis at negative 2. Now, before I even draw it, before you draw it, if you have a pen, don't do it right now. Okay, don't do it right now if you have a pen. You have to have a pencil, you have to have an eraser. Okay, so y equals negative 2 is a horizontal line that crosses right through like that. Okay. Now, the condition, this is where we need the eraser. The condition is if x is less than negative 3. So x is less than negative 3. You need to go to the x-axis. Here's the x-axis. You need to go to negative 3. That's positive 3. Go to negative 3. And you only have to show the less than part of it. So to the left. You don't want to show it to the right. You want to show the less than part of it to the left. And it's going to be an open dot because it does not have a solid line underneath your inequality. So what I recommend is to get a little post-it paper or a different, just at the beginning, get any type of paper. I'm just going to draw a little box. And I'm going to put that paper at the x value of negative 3. See that? So this is the only piece I want to show. Okay, so I need to erase all of this. And it needs to be an open dot. So I'm going to erase this, but also put an open dot right there. That's what I'm going to do. So that's what we need to do. Let's do that. Let's erase it. And put an open dot right there. And now we could move on to the next one. The next one I'll do in red. Okay, so that one's saying y equals, whoops, that's not red. Y equals negative 2/3 x plus 1. I like to rewrite it. It just helps me. It might help you. You don't have to, but if you want to, go for it. So that one crosses at 1. And again, you need an eraser. If you have a pen, don't do it until we're done. That way you could get the right graph. It crosses at positive 1. From that point, you go down 2 over 3. And you could use that pattern backwards of up 2 over 3 in the other direction. And you could continue that pattern, but you would be off the graph. Anyway, here's my line, but we do need to erase. So what are we going to erase? Depends on the condition. The condition right here reads that you only want to show the line from negative 3 all the way to 0. Okay, it's a compound inequality. You want to show it from negative 3 all the way to 0, and we're talking about the x values. So if we go to the x values, you could get a post-it and go to the 0 and put a piece of paper right there, right at 0. And you could get another piece of paper and put it at negative 3. So you get that piece of paper, put it right there at negative 3. And this little segment from here to here, that's all you want to show. You want to erase everything out here, erase everything down there. So if you have 2 pieces of paper, I have Post-its at my desk. You guys could get some Post-its if you want to cover so you could see what you want to show based on the condition. So you need an eraser. That's why we are going to erase all the way to -3. And we're going to erase to 0. And both of them will be solid dots, which they already are solid, right? I mean, you can make them bigger if you want. Let's move on to the last one. The last one, I'll do in green. Y equals 4x minus 3. And like I said, it helps me to rewrite it. Y equals 4x minus 3. Algebra 1 tells us that it crosses at the b value of -3. That's the y-intercept. From that value, I go up 4, 1, 2, 3, 4 over 1. Up 1, 2, 3, 4 over 1. And I could even go down 1, 2, 3, 4 over 1 in the other direction. But the bottom line is this is my line. And now, of course, I need to go to the condition that x has to be greater than 0. So you only want to show at the x value of 0 to the right. X is greater than 0 means you only want to show x being at 0 to the right. So you don't want to show anything on the left side of it. So this is where it begins, and it will be an open dot right there. So let me erase this part. It'll be an open dot. And there's my piecewise function. Any questions? So there's a lot more to piecewise functions than just graphing a piecewise function. We're also going to be looking at the graph and writing the piecewise function. But there's even more than that. So let me take a pause right here. Let me go over here to the side. And remember, a function is like a machine. You plug in a number for x, you pull out an answer for y. Right? And those inputs and outputs are technically x and y values. You could name your function machine whatever you want. You could name it f of x, g of x, h of x. So let me just say that there's a function called r of x. And let's say that function is a -2x plus 8. I don't know, right? Now, there's this thing that we call function notation. Function notation looks like this. R of, let's say, 5. Yeah? Now, that notation says an entire sentence, or maybe even more. You see, what r of 5, it doesn't say r times 5. It says r of 5. And what that really means, it's the instructions that they want you to plug in the number 5 into the x values of your r of x function. That's a lot of words. It's a long sentence. So instead of me saying, hey, I want you to plug in the number 5 into the x value of your r function, I just say r of 5. That's a quick and easy way of me telling you that. So what would the answer to r of 5 be? This is also Algebra 1 stuff. You just, there you go, -2. Because you really have the function -2x plus 8. And of course, we're plugging in the -5. Oh, wait, not -5, +5. Why did I say -5? +5. So I'd get -10 plus 8, giving us the -2. Are you with me? All right. So with that knowledge, let's ask you the same exact thing, but about this piecewise function. Okay? What if I told you to find f of 5? Somebody's excited. F of 5. Now that means take the number 5 and put it into the f function. But this f function is not a regular function, it's a piecewise function. So where am I going to plug it into? Because there's several pieces to this function. Do I plug it in right here to this x? Do I plug it in right here to this bottom x? Am I going to use the top one? I don't know. Which one do I use? It all depends on your condition, ladies and gentlemen, right?
Why 5?
So what is this 5? It's really the input. What is an input? It's an x value. So if you're wondering, do I use the top one, the middle one, or the bottom one? The conditions tell you what to use. It tells you if your x values are less than -3, this is a 5, right? And the 5 is an x value. So is this 5 less than -3? No, so you're not going to use that first one. Is 5 between -3 and 0? No, so you're not going to use this red one either. Is 5 greater than 0?
Yes.
Yes, so we're going to use that bottom one. So somebody tell me what the answer will be. 17. right? Because, I mean, the actual work, 4x minus 3. And we plug in a 5 right there. 4 times 5 is 20. 20 minus 3 is 17. Cool? All right, what if I asked you to plug in, let's say, f of negative 3? The second one, the middle one, right? Okay, and what would the answer be?
3.
It'd be 3, right? Now, I'm going to show some work, right, so I don't mess up. We're going to use the second one. That second one is, let me rewrite it to be safe, negative 2/3 x, I put parentheses instead of x, plus 1. I just rewrote it, negative 2/3 x plus 1, there it is, negative 2/3 x plus 1. I put the parentheses because they want us to plug in a negative 3. That's exactly what I'm going to do, plug in a negative 3. If you want to multiply a fraction times a number, you could put it over 1 and then multiply the top with the top and the bottom with the bottom. When I go negative 2 times negative 3, that will give me a positive 6. When I go 3 times 1, that'll give me a 3 plus 1. That's really 6 divided by 3 plus 1, which is really 2 plus 1, which is really 3. Cool? So f of negative 3 is 3. You're probably thinking, why are we doing this? Because these questions will come out on the quiz also this Friday. Okay? This one is like the most interesting one here. What if I asked you to do f of negative 5?
Then it would be the first one.
Okay, so it'll be f of negative 5 will be the first one because negative 5, it's not greater than 0. Negative 5 is not between negative 3 and 0. Negative 5 is definitely less than negative 3. So we will be using the first one.
Yeah, but there's no x on it.
But there is no x, and we know that they're wanting us to plug in this x value, but there is no x value. So what is there? There's just a number, which means that your answer is just that number, negative 2, equals negative 2. Because there's no math to do. There is no x to actually plug it in. So that answer is negative 2. And it doesn't matter which one. Like if I said, what is f of negative 352? Well, where's negative 352? Same deal. The answer will be negative 2. And that's it. Most of the time we have some math that we have to do, like negative 2/3 times x plus 1. Then you get your answer. That'll be your answer. But right here, it's just a number. It doesn't matter if it's negative 2 or 7 or 15. If it's just a number with no x where you could actually plug it in, then that number will be your answer. Yay?
Yeah.
Okay. So anyway, that's the algebraic way of finding f of 5, of finding f of negative 3, of finding f of negative 5. There's a visual way of doing it. If you have, and there will be some questions like this also, I will give you the graph of the piecewise function, and then I'll ask you to find f of negative 3 just based off of the graph. Now, what we really need to do is understand what this number is. We should know that it's the x value because we plug it into the x value, right? And when we get out an answer, that answer is a y value. So technically, the input negative 3 gave us the output positive 3. And we got that output by doing all that math. But if we look at a graph is all about inputs and outputs. It's all about coordinates, which are really inputs and outputs, which are really x values and y values. So if I look at the input negative 3, let me rewrite it over here, f of negative 3. Instead of doing the math, if I already have the graph, I could just go to my x value of negative 3, negative 1, negative 2, negative 3, and then look at the y value, or is it down here or is it up here? This is an open dot. That means it doesn't include it. Up here it's a solid dot. So at negative 3, where are we at? We're at positive 3 on the y. This is the coordinate negative 3, positive 3, isn't it? That really means that for the input negative 3, we get the output positive 3. So I could have just known the answer just by looking at the graph. What if I asked you to do f of 0? What would the answer be without doing the math? I mean, you could do the math, but without doing the math, 1. The answer is 1. Why is that? Because the input 0, the x value of 0, well, it's either going to be down here or up here. That's an open dot. It can't be that one. That's a solid dot. It's this one. So your input of 0 gave you the output of 1. The coordinate is 0, 1 right there. What do you think? Yeah? Okay, what about visually, what is f of 2? What is f of 2? 5 is exactly right. Because when you go to the x value of 2, what is your y value? When you go to the x value of 2, your y value coordinate's way up here at the y value of 5. Cool? Now, that 2 giving you a 5, you could have done that algebraically if you wanted to. You would just have to decide, where do I plug in the 2? Do I plug it in here? No, 2 is greater than -3, not less than. 2 is not between -3 or 0. 2 is greater than 0. So you plug it in right here. 2 times 4 is 8. 8 take away 3 is 5, which we were able to do that, get that answer 5 just by looking at it visually. On the x at 2, the y value is 5. So there's a great advantage to be able to have the graph there already for you. Okay guys, so I've had a video already posted explaining the majority of this worksheet. I'm just going to go over a couple of more, especially ones that we didn't cover on the previous video. Like number 3, for example. Let's first understand this. I give you an f of x function, I give you a g of x function, and I give you an h of x function. So first, you have to begin by understanding which one you're going to use. On number 3, we're going to be using the g function, right? What are we going to be doing with the g function? We're going to be plugging in the value of 0. The input will be 0. So in addition to knowing which one we're going to be using, which is a g function, you need to know which part of that g function you're going to be using. So is 0 less than -1? No, so you're not going to be using this top one. Is 0 between -1 and +1? Yes, so you're going to be using the middle one. Now the thing is, the middle one has no x value to input. It's just a number. So if there is no x value to input, then whatever number's here, that will be your answer. Make sense?
Yes.
Okay, so what is my answer for number 3? 0. That's exactly right. Let's look at another one that's not explained on a previous question. F of 5, number 6. So we're going to go to the f function. That one only has 2 of them. You know what? I'm going to rewrite it just right here so you can see it. F of 5. So I need to plug in 5. Where am I going to plug it in? To the top one or the bottom one? Bottom one, right? Why the bottom one? Because 5, the input 5 is definitely greater than 2. Okay, and if you're thinking, oh, but it's not 2, what about the equal? It says greater than or equal to. So as long as it's greater than or equal to, use the bottom one. So what would my answer to f of 5 be if we're using this bottom function y equals x minus 1? The answer would be 4, because x minus 1, and you plug in this 5, it's going to be 5 minus 1, which is 4. So that's your answer for f of 5. F of 5 will be the answer 4. Okay, again, it was 5 minus 1, which gave us that answer 4. Let's take a look at number 7, g of -3. G of -3. I'm just going to rewrite it right here so we don't have to move back and forth. G of -3. So I need to plug in -3. Where am I going to plug in -3? Into the first one, the top one, right? When I plug it in, what will my answer be? Okay, so and I heard some right answers, but I want to be crystal clear here. Whenever you plug in a value, it's probably better to rewrite your expression with the parentheses, right? So what does this say? It says -x. I'm going to rewrite that as negative parenthesis. And now I could easily plug in the input that they want me to plug in, which they want us to plug in -3. So when I plug in -3 right there, we end up with a +3. So that's my answer, +3. So g of -3 is really +3. Now, honestly, this stuff is not hard, but you got to you got to pay close attention to the details. You got to know which part you're going to do based on the condition. Then you got to carefully plug it in. I recommend using parentheses. So g of -3 is +3. That's your answer. Again, because the original function said y equals negative x. Let me do that. Let me show y equals negative x. And of course, when you plug it in, use parentheses, and you're plugging in that negative 3 right in there. So y ends up being 3, or in this case, g of negative 3 ends up being positive 3. What if I were to ask you, these aren't even on your worksheet, let's just go random here. What if I were to ask you h of, let's say, negative 10. So what's my answer going to be of h of negative 10?
H equals 3.
It's just going to equal 3, right? H of negative 10 is just going to equal 3. How about h of positive 10?
No. You would use a third.
Somebody said it? 13.
Yeah.
13 is correct. Now if you're thinking, what the heck? Well, you got to know which one you're going to use. Are we going to use the top one? Is 10 less than negative 4? No. Is 10 between negative 4 and negative 2? No. Is 10 greater than negative 2? Absolutely. So I know I need to use this one. So I'm going to rewrite this, 3 halves x minus 2. I'm going to rewrite it. 3 halves x minus 2. And I am plugging in the number 10. So you could just multiply, top with the top, bottom with the bottom. 3 times 10 is 30. 2 times 1 is 2. And then we have the minus 2 at the end. So you have 30 divided by 2 minus 2. 30 divided by 2 is 15. 15 minus 2 is final answer 13. I apologize for the mess, but that's your answer. Is this making sense?
Yeah.
Okay. So this whole first section, it's really simple. There's not much math to it, especially because a lot of times, I mean, we're expecting to see functions like y equals 3 halves x minus 2, or maybe 5x plus 13, or something complicated. But on these piecewise functions, a lot of them are just like a number, or just like just x, or so a lot of them are really easy. Don't get confused. If you're stuck and want to see more of those explained, you could definitely find them on the other video that's already posted. Down here, it says graph the piecewise functions above, then state the domain and range of the following piecewise functions. So we have number 9 being the f of x function. You actually have to graph that piecewise function that's called f of x. Okay. And then we want to do the g of x function right here, which is right there, and the h of x function obviously down there. So all three are already explained on a different video, but I could explain one to you right now. Which one would you like to see? Number 9, 10, or 11, the f of x, the g of x, or the h of x? F of x, the first one?
Yeah.
All right, let's take a look at the first one. Now, I highly recommend that when you're drawing your piecewise function, of course, you need an eraser, use a pencil. But in addition to that, I would recommend rewriting your equations. For example, the first equation is y equals 2x. I'm going to rewrite that exactly, y equals 2x. I could put plus 0. I could put 2 over 1x. It's all the same thing. The bottom line is I need to graph y equals 2x. It crosses at 0. I go up 2 over 1, up 2 over 1, and I use the pattern backwards, and there's my line. It's ugly, I'm sorry. But there it is. Now I still need to get the condition. The condition, as you can see back up here, is that your x values have to be less than 2. So you could get a piece of paper, take that piece of paper, put it at the x value of 2 on the x number line. Boom, right there. So I only want to show the left side of it because it says x is less than. Less than is to the left. Greater than is to the right. So anyways, less than 2. So here's 2. Less than would be from here this way. So I want to show all of this. I want to erase this top part. This little piece, I need to erase it. And it's going to be an open dot right here. Why is it open? Because it does not have a solid line. Solid lines do produce solid dots. Right here we don't have a solid line. So we need to put an open dot. So let's erase this arrow. Let's erase that dot, and let's put an open dot right there. Sorry about that. It's taking a while. And that is my first piece. Now my second piece, I want to use a different color, blue. Y equals x minus 1. And again, this really helped me back when I was learning piecewise functions. I would rewrite it y equals x minus 1. We know that that guy crosses at negative 1. And I do go up 1 over 1, up 1 over 1, up 1 over 1, and so on, and it continues forever in both directions. However, the condition, what does the condition say? It goes that way and this way forever. But what does the condition say? The condition says if your x values are greater than or equal to 2. So that would mean, like, take a piece of paper and put it at 2 and show the greater than side of it. Greater than's to the right. So let's put that piece of paper at 2 right there. And you only want to show the right side of this blue line, which is from here that way, which will be a solid dot right here. Erase everything else. So that's what I'm going to do. I'm going to erase everything else. And you could make that solid line a little bit bigger if you want. But that is my piecewise function right there. Any questions? What about the domain and the range? This one's pretty easy. The domain, or does the entire piecewise function go to the left and to the right forever? Isn't that right? So we would say x equals all real numbers. Now here's an interesting fact, ladies and gentlemen. It's all real numbers because every single x value is accounted for. There are no gaps. Now what do I mean by that? Right here's the x value of negative 2. Right here's the x value of negative 3. You could go to negative 10. It'll just be way down here somewhere, right? As you go this way, at the x value of 2, there's an open dot up here, but it does have a solid dot down here. Now, if you had an open dot right here, if it were, let's say, open, then you'd have a hole right there and a hole right here, which would mean x equals all real numbers, but x cannot be the number 2 because there is no value at 2. There is no y value at 2. It's 2 open holes. Now, that's not the case on this particular problem. There's a solid dot on the blue one, open dot on the red one. But it will happen at times where you have a gap, a hole, where you have to say that can't be it. Anyways, how about the range? Y is all real numbers, okay? Because it does go up forever, it does go down forever, there are no gaps. There are no gaps. Okay, so number 12, we need to write the piecewise function. It says name this one h of x. So everybody should go down here and put a h of x equal sign, some pretty huge brackets taking up that whole space, because you're going to have to write 3 different equations in there. And of course, you should be able to do that on your own. And there's already an explanation of that video previously that explains how to do this. Now, in addition to that, down here, questions 14 and 15, they tell you to state h of negative 3 on number 12. So you don't even have the function, but I want to prove a point here. You don't even have the function, but if you have the graph of the piecewise function, you could and you should be able to answer the question h of negative 3. Does anybody know what h of negative 3 is based on this h of x piecewise function graph? H of negative 3. I mean, you would have to look, do I use the top one? Do I use the middle one based on the conditions? But we don't even have that, but we do have the graph that represents all the answers already. So what would h of negative 3 be? Question 14, state h of negative 3. Even without the actual piecewise function, I could get the answer from here. H of negative 3 is negative 1, exactly right. Because when I say h of negative 3, I'm really saying what is your output when I put the input negative 3 in there. Inputs are your x values. Go to negative 3 on your x, negative 1, negative 2, negative 3. Where's your graph at? It's right there. What is that coordinate? Negative 3, comma, negative 1. So negative 3 is the input, negative 1 is the output. Pretty crazy, right? You could get these answers without doing any math, okay? over here on this one, yes, you're going to have to name this one f of x. You're going to have to write smaller on this one because there's less space. So you're going to have to write the piecewise function pretty small down there. But then it also says state f of negative 2. And you could do that without the piecewise function. You could just look at it and state your f of negative 2 answer. It'd be a different story if I told you find f of 10, right? Because f of 10 is way off the graph. So then you would have to resort to algebra in order to find that one. Anyways, I think this video is already long enough. Are there any questions before I end it? No? Okay. Let's practice, guys. Work on that worksheet. Okay, so I'm going to throw in this final explanation on this guy. We want to state the f of x function, okay? And we want to state the domain and range. So whenever we look at these guys, I recommend looking at it from left to right. We do see a solid dot right here going this way forever. And what line is this piece from? I mean, you could imagine this line is really going this way forever, right? It's a horizontal line that crosses the y-axis at negative 2. So what is that equation? Y equals negative 2. So we have the y, we have the equal. I'm going to put a negative 2 right here. But of course, if you drew it, please erase it because that's not there, right? Now, what is the condition? You only see from the x value of negative 3 to the left. So how do we say that as a condition? If x is what? Less than or equal to negative 3. Now, if you're freaking out, you could use a piece of paper. Be like, where does this line, where's the end point? It's right there. Where's that? It's at the x value of negative 3, going to the left. So x is less than or equal to negative 3. Are you guys with me? Yeah. Okay, let's go for the next one. The next one I'm going to do in blue. Open dot from here to here. So that piece comes from what original y equals mx plus b line? That piece comes from what original y equals mx plus b line? Do we know the m? Yes, the m is negative 1 over 1, right? Or just negative 1. So y equals negative 1 over 1 x. And what's the b value? 4. Plus 4. So there's my equation. Y equals negative 1 over 1 x plus 4. Now, instead of writing it as negative 1 over 1 x, I'm just going to put negative x. So the second piece is y equals, which is f of x equals negative 1 over 1, which is just negative x, plus 4. And now I need a condition, because y equals negative x plus 4 is the entire line going that way forever and this way forever, and we know that that's not the case. So it's between which x values? You could use a paper to show you the x value right there, and you could get another paper and put it over here, which shows you the x value of 0 and the x value of negative 3. So it's between negative 3 and 0. So the condition is really simple. You put if, put the smaller number on the left, the bigger number on the right, the x in the middle, less than symbols, and then worry about if you have solid dots, you put solid lines underneath the inequalities, which we don't have solid dots. Those are open dots. Yay? Yes. Okay. Last one, solid dot at the origin, going this way forever. This is a piece of a line. What line are we talking about? The line y equals what? What's the slope? 1 over 1 x. What's the b value? Plus 0. Of course, we don't have to write 1 over 1. We don't even need the plus 0. We're just going to say y equals x. That's exactly right. Y equals x. Now the condition, if, well, what part of the line do you see?
If 0 or x is equal to or greater than 0.
Greater than or equal to 0. That's right. It's a solid dot, so it's going to be if x, whoops, sorry about that, if x is greater than or equal to 0. Now, I do want to mention this, the domain are your x values. Does it go to the left forever? Yes, the red line shows that it goes to the left forever. Does it go to the right forever? Yes, the green line shows that it goes up and to the right forever. So yes, all real numbers. There are no missing gaps. What do I mean by missing gaps? Here's an open dot. This one's a solid dot. There's no missing gaps. If it were open and open, they'd have something missing. You'd have to do something else. Let's talk about range. Range is interesting. The range values.
It would be
Y is
greater than or equal to 0.
greater than or equal to 0. That's great. Now, some people would say y is greater than or equal to -2 because they see that this is the lowest y value, -2. But if you say greater than or equal to -2, you have this gap right here. There's a gap right here. From -2 to 0, there's a gap. So you do want to say y is greater than or equal to 0 because from here up, yes, it's representing all that. But in addition to y is greater than or equal to 0, you also want to say, or y could also equal -2. So there's your complete correct range. Y is greater than or equal to 0, or y could also be -2. Does that make sense? Okay.